Righto. So let's continue on with this. The second example, I've got f of x equals that. So I'm just going to say u equals e to the 2x and v equals sine of 3x. And from that we can get du dx is 2e to the 2x and dv dx is just going to be 3 cos of 3x. And so we need to put this into the rule again. Sorry about that. Put this into the rule again. So dy dx, or perhaps I should say f dash x, so f dash x, I'm just going to stick with the Leibniz notation here. Well, perhaps I'm going to be a little bit lazy and just not even worry about it. So it's v du dx, so that's 2e to the 2x sine 3x plus, sorry, that's meant to be a minus. Maybe I should have written out the rule. Yeah, minus u dv dx, so that'll be 3e to the 2x cos 3x, and then that's all divided by v squared, so divided by sine squared 3x, and that's it. Now I'm going to jump into the last example, which is over on my other one. So in an earlier video I talked about proving the derivative of tan x. So we want to prove that it's equal to sec squared x, and I would like you to have a go at doing that. So what I'm going to suggest is that in a couple of seconds time you pause the video and work through it, and then I will do my solution as well, and you can check to see how you're going with it. So if you get stuck along the way, continue watching the video until you get to your point, and go on from there. Anyway, I'll start my solution in 3, 2, 1. Right, so first thing I'm going to do is I'm going to write it as y equals sine x over cos x, which means u equals sine x and v equals cos x. And so from that we can get du dx is equal to cos x and dv dx is equal to negative sine x. So we sub these into the rule. Dy dx equals v du dx minus u dv dx all over v squared. So subbing those in, we get cos x times cos x. So cos x times cos x, I'm just going to write it as cos squared x, minus, and then we've got u dv dx, so it's sine x times negative sine x, which is negative sine squared x. When we put that in here, it's going to make this positive. So it makes it plus sine squared x. And that's all divided by v squared, which is cos squared x. Now this is almost ready to go here. The thing we have to identify next is the fact that, well, cos squared x plus sine squared x is just equal to 1, using the Pythagorean identity. So that's actually just equal to 1 divided by cos squared x, which, as we know from the other video, is just equal to sec squared x. Okay, remembering that the third letter tells you what it's over. Anyway, that was the proof for it. Perhaps you used an extra step or two in getting to this. You might have written it as cos x plus or minus sine x times negative sine x and so on. But this is what you should have ended up with in the end. So anyway, that's it for the proof, and well, pretty nice one I thought. Anyway, I will see you all in the next videos.